presenting the slideshow for this week. Okay, so here we go. Um, we covered a lot this week, and I know I've heard from several different people that this was hard and they had lots of questions and stuff like that. So, hopefully, by the end of this meeting, your questions will all be cleared up. This will be a kind of long meeting. I hope it doesn't go over an hour, but we'll, I'll go through it as quickly as I can. Um, please stay until the end because when you start doing, if you haven't already started your work, if you start doing it, you're going to have questions. um, if you have already finished it and you feel good about it, then feel free to zone out or whatever. I'm not trying to waste your time. I just know that if I go through all of this and then you come back with a question that I already answered during this meeting, um, it's just hard to answer everybody one on one just to have time to do it. So I'm not trying to scold anybody or anything like that. It's just try to hang in. All right. So let's get started. Pythagorean theorem was the first thing that we talked about for this week. This should be review for most of you. I had a few, especially those who skipped eighth grade math, and that have not seen this before. So this was definitely something that needed to be covered. Not only is it important on its own, but also when you get to the trig, you oftentimes use the Pythagorean theorem. So I needed to make sure that everybody knew that. Pythagorean theorem only works on a 90-degree triangle. So this would be the 90-degree angle right here. It's not marked, and it really should be. We can't just assume that anything is 90 degrees, but this one is just not marked. So this is a 90-degree angle. Across from the 90-degree angle is the hypotenuse. Hypotenuse is really important. It's important in Pythagorean theorem, and it's important in trig. You have to know the hypotenuse. The hypotenuse is across from the 90-degree angle. It is the longest side, and in Pythagorean theorem, it is always marked with a C. A squared plus B squared equals C squared is the Pythagorean theorem. So if the hypotenuse is not the C, it's going to mess everything up. So hypotenuse is always C. A and B are the legs of the triangle, and they're interchangeable. This one could be A or B. Same. This could be A or B. That doesn't matter. C matters. C has to be the hypotenuse. So A squared plus B squared equals C squared. Okay, then I have a whole video on just nothing but Pythagorean theorem and how to use it. And here's some Pythagorean theorem questions. Looking first, I'm going to skip all the way down to number 9. Looking first at this one, you have a whole right triangle. Here's the right angle right here. And across from it is the hypotenuse, which is 12 units long. Now, I don't have this leg or this leg, so I don't have enough information to solve. So what I'm going to have to do is break this down into 2 little triangles. You can tell I've already done this with the other classes. I forgot to move the answer. Hey, stop. There we go. All right. So if I put my cursor there and just block the right triangle and only look at the left triangle with 9, 5, and X. 9 and 5 are the legs. X is the hypotenuse because it's directly across from the 90-degree angle. So 9 squared plus 5 squared equals x squared. 9 squared plus 5 squared equals x squared. Okay, so what am I trying to, oh yeah, lost my mind there for a minute. Okay, so this is the kind of calculator you're going to have on your state test next week or tomorrow. Some of you that are virtual might be taking it tomorrow or next Friday. But most of you that are coming in will be taking it next week. And this is the kind of calculator that's on the state test. So by now, after I waited and tried to figure out where I was going, I forgot what the numbers were. Okay, 9 squared plus 5 squared equals x squared. So you just plug in right here. I'm going to put in 9. Now I can come down here and grab this calculator and get the squared. Plus 5 squared. You can click these numbers or type them in either which way. So 9 squared plus 5 squared is 106. So c squared equals a squared plus b squared. So c squared equals 106. Well, I don't want c squared, I want just c. So I take the square root of both sides. The square root of c squared is c. The square root of 106 is 10.3. That's rounding to one decimal place. 10.3. Okay, then to find the other side, it's the same thing. The hypotenuse is the y. So I have 3 squared plus 5 squared equals y squared. So 3 squared plus 5 squared is 34. Okay, 3 squared plus 5 squared equals c squared. That's 34. Take the square root of both sides. And the square root of 34 is 5.8. So this side would be 5.8. Now the hypotenuse is always the longest side. 5.8 is longer than 5. 10.3 is longer than 9. So make sure your answer makes sense. So that's that problem. Now I'm going to jump back to this one where I have the hypotenuse. The longest side is 30. It's either A or B that I'm looking for. So let's just say this is A. So A squared plus 24 squared equals 30 squared. Hang on. Okay, so we just said A squared plus 24 squared equals 30 squared. Okay, so I want to get A squared by itself, so I'm going to subtract 24 squared from both sides. So let's look at the calculator. 30 squared minus 24 squared is 324. So that leaves me, hey, where'd my Jamboard go? Why'd it go away? Sorry, hang on. All right, so I did 30 squared minus 24 squared because I subtracted 24 squared from both sides. So that leaves me A squared equals whatever that was. And so then I would just take the square root of both sides. So that would give me A equals, and I need the square root of this. So that's the square root of 324, which is 18. Now, if I go back and look, if I plug in 18 right there and look at it, 18 is longer, that side is longer than this side. And 18 is definitely not bigger than 24. So that doesn't make sense, or it doesn't look like it makes sense. Now, what I would guess is this just isn't drawn to scale. But we don't want to guess, we don't want to assume. So I'm going to go back over here and I'm going to type in 18 squared plus 24 squared. That's 900. And that should equal 30 squared, which is the hypotenuse squared. That's 900. So they do equal. So it's just not drawn to scale. I hope that doesn't happen on your test, but it could. It honestly could. So just make sure that your math works, even if your picture looks off. Over here, we looked at the picture and we said, okay, well, that is definitely longer than this, and this is longer, because we know that the hypotenuse has to be bigger than any other side. The hypotenuse is the longest side. So as long as the hypotenuse is the longest side, and as long as your math works out, then you've checked everything you know to check. Okay? So any questions about Pythagorean theorem? I know everybody's on mute, so if I don't hear anybody pipe up, I'm just going to move on. Okay, then looking at the trig, first mistake. I always have mistakes. I can't go without mistakes. My first mistake is that I said you've got sine, cosine, and tangent. That's true. And then I said they're almost always abbreviated as this, and I wrote out tangent. Tangent is abbreviated just TAN. You still pronounce them sine, cosine, and tangent. You say the whole word, but when you write it, or when you're looking at your functions on the calculator, you're only going to see the 3-letter abbreviations. Okay, this slide 6 and slide 7, they're just lots of information kind of written in different ways. The thing that I liked about slide 6 was this little, what do you call those things when you, mnemonic or something like that? No, that's not really what it is, but it's just a little memory device. Go Soka your Toa.
Acronym, is that it?
Acronym.
That's not an
Yeah.
acronym. I
I
didn't look at it.
I don't know what the exact word would be, but anyway, it's just we're gonna just remember Soka Toa and SOH, CAH, and TOA are explained right here. And that's what I liked about this slide is it has everything all written out so that you can see exactly what the SOHCAHTOA means. So sine, cosine, and tangent are not on your cheat sheets for the test next week. If you memorize them, good. If you don't, fine. It's, this test, guys, I am doing more preparing for this because of you, because I don't want you to go in there and go, dang, she didn't teach us any of this. I'm wanting you guys to know a little bit about everything that's going to be on it before you go in there. And there's just no way we could have covered everything with this crazy semester like it's been. So, I'm just trying to expose you to as much as possible. But when you get in there and you start taking this test, please don't panic. Just go, okay, well, there's something she didn't get to. Okay, well, there's something I don't remember. Because guess what? Your lives are more important than geometry, and you've had a lot going on, a whole lot going on. So just don't feel bad about it. I'm doing this for you so that you will know some stuff before you go in there, but just don't sweat it. Don't sit around studying all weekend long. Just listen to what I have to say and then do your best. All right. So here's all the trig ratios. And again, we have a way to memorize them. So it shouldn't be too hard to memorize. Again, if you don't, you don't. Don't panic. All right. So here they are. Now let's put them to use. On this first IXL assignment, couple of things I want to say about it real quick before we get started on it. One is I always have questions pop up, random questions, when I'm trying to make an assignment. And I look at the random questions and determine, is this what I want to assign or not? This was what I wanted to assign based on the random questions that I got. However, they never got as hard when I was looking as they actually do in this assignment. And they come on pretty hard, pretty quick. So we're gonna talk about that as I go through this. Um, Also, is changing the way that I'm grading. I'm not grading on your SMART score for this assignment. And if any of you have tried this already, that ought to be a huge relief because it does get hard. All right, so let's try it. This is only just using. It's not solving anything. We're not looking for any angles or any sides or anything yet, which is what we use trig for. This is just recognizing what the trig functions are. Okay, so in this one it says find the cosine of angle Q. Well, here's angle Q right here. And cosine in the SOHCAHTOA, cosine is the C, C-A-H, and the AH stands for adjacent over hypotenuse. All right, the hypotenuse is always the side across from the 90-degree angle. So the hypotenuse is 89. Adjacent is it touches the angle that we're talking about. In this case, we're talking about Q. Well, the hypotenuse touches Q, and the other side to touch Q is 39. So 39 is adjacent, 89 is hypotenuse. So the cosine is adjacent over hypotenuse. And you always reduce it if you can. In this case, you can't. Brilliant. All right, so now I'm finding the cosine of angle S. So here's angle S. Here's the hypotenuse. That's always the easiest to find because it's across from the 90-degree angle. So identify that right away, even if you don't need it. You still identify it, and you know then that the other two are going to be what you have to worry about looking for. Okay, so cosine is adjacent over hypotenuse. Adjacent is part of S, beside S, and it's over hypotenuse, which we identified as 13. So this would be 5, the adjacent side, over 13, the hypotenuse. All right, this one is a sine problem. The sine of x. Sine is opposite over hypotenuse. So in SOHCAHTOA, so is SOH. So opposite, which is opposite the x, that's 70, over hypotenuse, which is opposite the 90-degree angle, so that's 74. So I have 70 over 74. Now this one can be reduced because those are both even. So I can reduce at least, I can divide at least by 2, maybe something bigger. But 2 goes into 70 35 times and goes into 74 37 times. I would say 37's prime, so there's not going to be anything to go into the 2 of those. So that's reduced form. All right. Cosine W. Here's W. Cosine is adjacent over hypotenuse. Hypotenuse is across from the 90-degree angle. So here's the hypotenuse. Adjacent has to touch W, so it has to be the 10. So 10 over 26, which reduces to 5 over 13. Super duper. All right, now we're looking for the sine of R. Sine, so, is opposite over hypotenuse. And opposite R, oh man, we don't know. We don't know what's opposite R. We know what the hypotenuse is, though. It's 17. So it's going to be something over 17. Now, to find that something, I'm going to have to use the Pythagorean Theorem. So that would be 8 squared plus the something, we'll call it b. 8 squared plus b squared equals 17 squared. 8 squared plus b squared equals, what did I say? I forget already. 17. Okay, 17 squared. All right, so that's how I'm going to set it up. Thought that would be faster than trying to write on that Jamboard, but I don't think that was any better. All right, so 8 squared is 64 plus b squared equals, what's 17 squared? 289. All right, so now I need to subtract 64 from both sides. So 289 minus 64 is 225. So now I have b squared equals 225. Take the square root of both sides, and b equals the square root of 225, which is 15. So 15 is this missing side. It's opposite r. It's opposite over hypotenuse. So 15 goes right here. And there you go. All right, this is a tangent problem, and we have lots of square roots going on. The rationals you might have done in algebra, but I think that would be later in algebra B and probably just touched on. You really get into radicals and rational numbers in algebra 2. So why they throw this in geometry, I'm not sure. So this is not, I did not ever see anything like this. I saw the Pythagorean Theorem, but I never saw anything like this when I was assigning this. So this is where it gets really hard, where I would think that, you just wouldn't really know what to do. And some of you might. I might be wrong. But here's what we should do. All right, so the tangent of G, here's G. Tangent is the toe apart. Tangent equals opposite over adjacent. So opposite G is 2 square root of 14, and adjacent is 2 square root of 10, because this is hypotenuse, and with the adjacent's the one that touches the G that's not the hypotenuse. So opposite 2 square root of 14 over adjacent 2 square root of 10. All right, so let me turn my pen on. 2 square root of 14 over 2 square root of 10. We're going to cancel the 2's because 2 divided by 2 is 1. So that's just basically gone. And then we have square root of 14 over 10. Well, over square root of 10. We cannot have a radical in the denominator. We have to get rid of that. So what we're going to do, I shouldn't have put an equal sign there. I should have put a multiply. What we're going to do is multiply by 1, but we're going to multiply by 1 in the form of square root of 10 over square root of 10, because anything divided by itself is 1. So we're just multiplying by 1, which does not change the value, but it changes the format. So now I have square root of 14 times 10, which is square root of 140, divided by 10. Square root of 10 times square root of 10 is 10. Because that's like square root of 10 squared. And when you have a square root and a squared, they cancel each other out and leave just the number. So I have square root of 140 over 10. Now you would think, okay, that's enough. That's got to be all. But unfortunately, it's not, because if you have a perfect square inside your radical, then you still are not done simplifying. And I know at least 4 will go into this, and 4 is a perfect square. The square root of 4 is 2, so it's a perfect square. Um, 16, does 16 go into 140 evenly? I'm checking. No, it doesn't. I just used the calculator. So I'm going to say 4 might be all. So I'm going to break that down to square root of 4 times 35.
10:36 a.m. is when that.
Okay, and that's all over 10. Now we're still not done. The square root of 4 is 2. I'm coming over here. So we have 2 square root of 35 over 10. And now we have to simplify the 2/10. 2 goes into 2 once. 1 times square root of 35 is square root of 35, so we don't need to talk about the 1. And 2 goes into 10 5 times. So I end up with square root of 35 over 5. Now, that is a whole nother lesson in itself. So if you didn't already know how to do this, then that's hard. So square root of 35 over 5 is what I end up with. And that should be my tangent. Okay. Now, it's not a good use of our time to keep doing those harder problems. Now that you've seen it, either you get it, you remember it from some time, I don't know when, but maybe you've seen it and done it. And if you don't, then hey, that's like I said, that's a whole nother thing that would take forever. So, um, what I'm going to do for a grade for this is I want you to get 5 questions correct. If you miss, now see, I've done 6, and you saw how hard that last one was. If you get up to 5 or 6 and you miss a couple here or there, whatever, you've only got 3 right so far, the 3 easy ones. Well, you miss the next ones, it's going to go back to the easy ones again. So you ought to be able to get 5 correct. So rather than the smart score, which is what I told you originally, that is not true. That is not the case anymore. Now you just need to get 5 correct on this IXL assignment. On the sine, cosine, and tangent, the trig ratios. This is exactly what it's called right here. On this one, you only need to get 5 correct. And I'll go ahead and tell you now while I'm talking about it, on the equations of circles, which we're also going to go over here in a minute, you only need to get 10 correct. Get 10 correct. Neither one is going to be based on the smart score like I had originally planned. This one, because it's hard, and the circle one, just because it's just repetitive. It's over and over and over the same thing. So get 5 right on this one, get 10 right on the other one. All right, so back to the slideshow. We've looked at that. Let's see. Here's just some more information. Then you have 2 videos that explain how to use the trig ratios. We haven't even done that yet. All we've done right now is identify them. We know what is adjacent, what's hypotenuse, what's opposite, how to set them up in these ratios. We know how to set them up. We have not used them yet. So, slide 12, we actually use them. So, taking a look at number 7, it says to find angle B and round to the nearest tenth. Well, when you're looking for an angle, you're going to always use the trig inverse. And I'll show you what I mean by that in just a second on the calculator. Anytime you're looking for the angle, use the trig inverse. Anytime you're looking for a side, you just use the trig function, just the way it is. But when you're looking for an angle, you use the trig inverse. And again, I'll show you that in just a second what I'm talking about. All right, so I'm looking for angle B. What do I have? I don't have the opposite. I do not have that. I do have a hypotenuse, and I do have adjacent. So I have adjacent and hypotenuse. So that's going to be cosine, because cosine is the one that uses adjacent and hypotenuse. So the cosine of angle B is 4.4 over 11. The cosine of angle B is 4.4 over 11. So what I'm going to do is I'm going to go over here to functions, and I'm going to say, okay, I'm looking for an angle. So I don't want to use cosine. I want to use the cosine inverse. Anytime you're looking for an angle, you use the inverse to the -1. And it was 4.4 over 11. So my answer is 1.2 because it said round to the nearest tenth. So this angle is 1.2 degrees. Well, that doesn't make any sense. 1.2 degrees would be almost closed. It would be like there was barely any opening in the angle at all. This is 90 degrees, so this can't be far behind 90. So let's take a look. Why? What did I do wrong? Well, that's the cosine inverse, like we're supposed to do. That's adjacent over hypotenuse, like we're supposed to do. So I've checked everything except for, aha, down here at the bottom, I have radians and degrees. Angles are degrees, they're not radians. Everything you do is in radians in math up to this point. Everything that you do is in radians. But now we're in degrees. So now it's 66.4, and that makes so much more sense. That looks like it could be about 66 degrees. So 66.4 is the answer here. All right, on this one, angle B is right here. I have the opposite, and I have a side that touches it. Is it the hypotenuse? Nope. I don't have a hypotenuse. So I have opposite and I have adjacent. The trig function that deals with opposite and adjacent, the only trig function that doesn't have hypotenuse is tangent. So I'm talking about tangent. I'm looking for this angle, tangent of B. And so since I'm looking for an angle, I'm going to be talking about the inverse.
No call.
So I go to functions, say tangent inverse, and it's 3 over 3. So the angle is 45 degrees. Just might want to check real quick. Yep, still in degrees. So it's 45 degrees. So I go back and my answer would be 45 degrees. Now, I want to point this out real quick. Based on what you already know from isosceles triangles that we did in the last week or two, I don't remember exactly which week, we know that if two sides are alike, then the two base angles are also alike. We also know that triangles add up to 180. So if this is 90, 180 minus 90 is 90. So these two angles have to add up to 90. They also have to be alike. So 90 divided by 2 is 45. So before I ever knew a thing about trig, I was able to find out that this angle was 45 degrees. So I'm telling you that just to say that there's more than one way to skin a cat 9 times out of 10. So if you get stuck on your test and you're like, crap, I don't know how to do what they're telling me to do, that's okay. Don't do what they're telling you to do. Do something else you know. If it's not working for you using the trig and you know another way, good, do it. Now over here, we didn't have any other way. There wasn't an alternative plan here, but here there would be. All right, now let's look for a side. When you're looking for an angle, it's the trig inverse. When you're looking for a side, you just use the trig function. So I'm looking for this side, and I'm given a 41-degree angle. You never use the 90-degree angle. Just act like it doesn't even exist. You'll never find sine, cosine, or tangent of your 90-degree angle. You just don't. So we're working with this 41-degree angle, and I have opposite. I don't have hypotenuse. I have adjacent. So I'm talking about tangent here. So the tangent of 41 degrees is 4 over x. So the tangent Oh, that's beautiful. Of 41 degrees is 4 over x. All right. So in order to solve this, I need to get x by itself. So I'm going to start out by multiplying both sides by x. So I have x tangent of 41 equals, and if I multiply this by x, the x's cancel and all I have left is 4. Okay, now to get x by itself, I'm going to divide both sides by tangent of 41. I know I'm not writing out 10. I just don't want to. It takes me forever. So the tangent of 41, tangent of 41 cancel, and x equals 4 divided by the tangent of 41. So I can go over here to my calculator, and I can say 4 divided by functions, the tangent, not the inverse, the tangent of 41. And I get 4.6. All right, looking back, 4.6 looks like a pretty reasonable answer for CA. And so that is what it would be. All right, angle B, 57 degrees. Across from it, I have opposite. I have hypotenuse. Opposite over hypotenuse is sine. So I know the sine of 57 degrees is 10.8 over x. It's going to work exactly like this one, except opposite over hypotenuse is sine. So I'm going to have the sine of whatever that angle was equals 10.8 over x. Multiply both sides by x, solve exactly like we did here. I'm going to leave that one for you to do, but you do it the exact same way. Use your calculator. You've got Desmos on your computer. You don't have to try to do that on your own. All right, and then last we have the circle stuff. Super easy. You have a video here in case you need help with it. Main thing you have to know here, I'm going to go to this learn with an example to show you instead of trying to write it on that Jamboard like I did earlier. It took me 100 years to write it. All right, so right here is the standard form of a circle. X minus h squared plus y minus k squared equals the radius. That's what the R stands for, the radius squared. And the center is hk. So like right here, the center is 0, 0. So you find the point where the center is, and then you plug that in for h and k. So it's going to be like x minus x from the center point plus y minus y from the center point, both squared, equals the radius squared. So that's what you're working with. This is really way easier than it sounds so far. All right, so on this one, my center is 0, 0 again. So x minus 0 is just x squared plus y minus 0 is just y squared. And that equals, what world? That equals the radius squared. And the radius is from the center out to any point on the circle. And it's 4 units. This is positive 4. This is negative 4. But still, all we're doing is counting how far. And it's 4. 4. So the radius is 4. And 4 squared is 16. So that's your equation for that circle. Okay, this one again, the point is at 0. The center point is at 0, 0. X minus 0 is just x squared plus y minus 0 is just y squared. And that equals the radius, which in this case is 2 squared. And 2 squared is 4. So there is your equation for this circle. All right, another one was 0, 0. I'm trying to keep going until I get to something different so you can see what to do different. Okay, so x minus 0 is x squared plus y minus 0 is y squared, and that equals the radius, which is 5, and 5 squared is 25. Okay, here's something different. It's not at 0, 0 anymore. Now the center is at 0, 9. 0, 9. So plugging into the formula, I would have x minus x from this center point squared. Well, the x is still 0, so I have x minus 0, which is x squared, plus y minus y from the point, which is 9. So I have to actually type that out. Squared. Y minus 9 squared equals the radius, which is 1 squared, and 1 squared is just 1. So this is my equation for this circle. All right, another one looks about the same. X is 0 again, y is 6. So x minus 0 is just x squared plus y minus the y and the point of this is at 0, 6. So y minus 6 squared equals the radius, which is 1 again. So 1 squared is 1. All right, this one's over here. It's at 8, 0. So this time it's going to be x minus 8 squared plus y minus 0 is just y squared. And that equals the radius, which is 1 squared, and 1 squared is 1. Okay, I was wanting to get into a negative. This is not getting there fast enough. So if you have a negative, let's just pretend like this one was down here at -4, the center. And so you would have y, the x would still be 0. So you would have x squared plus, and then where your y goes, sorry, you would have y minus -4. Now again, that's not talking about this one. I'm pretending like it's down here. Y minus -4. And remember that minus a negative is positive. So you're actually going to put y plus 4 squared equals the radius squared, which would in that case would be 1. And that's how you would handle that if it came up negative. If you had a point like say right here, and this was your center point at -2, 3, well then you would subtract 2. It would be x minus -2 and then y minus 3. So this would actually look like x plus 2, y minus 3. So just all you do is just plug in your center point wherever your center point is. Does anybody have any questions on the equations of a circle part? Alrighty then. Okay, then 15 and 16 are just extra. This is absolutely no grade for this. This is just for you. If you're a student that wants to do just as good as you possibly can on this exam, then you'll jump in there and take a look at it. And if you're just making it day by day, I understand. There's no grade on this. So that is the end. That wraps up all the work from this week. I hope that helps. Again, the trig, 5 questions correct. The equation of a circle, 10 questions correct. And we did almost everything on the slideshow. You only had 1 or maybe possibly 2 questions that I didn't answer that you need to go back and do on your own. So does anybody have any questions at all whatsoever? Alrighty then. I see a couple of people that I didn't see before. Let me make sure. Okay, yeah, I think that Timothy was added. Okay, all right. So, if there's no questions, then I will see you guys later. If I don't see you in person, good luck on the test. If I see you in person, you'll be testing with me. All right, bye.